All right, so this is a little extra practice for the solving absolute value equations that we've been working on in class. Um, we haven't got we haven't had a chance to really go over these in detail, so I wanted to make a little quick video for y'all to help you out. There's nothing new in that the steps are going to be very similar. Just they present it sometimes in a weird way, or it is presented in a weird way. So I want to make sure I explain it to you. So I'm going to look at number 35 here. Number 35, you'll see, is absolute value of 4n minus 15, and n absolute value equals absolute value n. So when I look at absolute value equations, your main goal is to always get your absolute value by yourself. Well, and if you look at the one on the left, you can look at the one on the right too, just it doesn't matter. If you look at the one on the left, is the absolute value by itself? The answer is yes. So just like before, if you can get the absolute value by itself, you then look at the other side to make sure it's positive. Well, it's absolute value, it's positive, we can continue with the problem. Okay? So here's what happens. When you have absolute values on both sides, one of the equations gets broken off into its original, just like before. Okay? And we're looking at this one over here on this side. Okay? The other one, the second equation, is always a negative one. So hopefully that sounds kind of familiar to what you've been doing. Only in this case, it's negative here, negative n. The solving is exactly the same, so you go through and solve, subtract 4n, you get negative 15 equals negative 3n, divided by negative 3, and equals 5. On the other one, same thing, subtract 4n, that gives you negative 5n. You have negative 15 here, divide by negative 5, divide by negative 5, and equals 3. So those are your two answers that you can plug in, they both work. We can go check them too. Take the 5, go plug it in up here. 5, 4 times 5 is 20. 20 minus 15 is 5. So absolute value of 5 is 5. Look over here. Absolute value of 5 is 5. Does it work? Yes, confirm right there. Do the same thing with the other one. Take the 3, plug it in. Move that screen there. Plug in 3 here. 4 times 3 is 12. 12 minus 15 is negative 3. Absolute value of negative 3 is 3. Over here, plug in 3. Absolute value of 3 is 3. Does it work? Yes, confirm. Both of these answers work. So you'll notice that just like in the previous examples that you solved for the absolute value of answers, it's the same steps. They just show it two confusing ways. Let's look at the next one. I want to look at number 39. 39 says 4 multiplied by, it looks like the distributive property, but it's an absolute value right now. P minus 3 equals absolute value 2p plus 8. Okay. Again, just like before, ask yourself, look at the left one. Okay. Is that one on the left, is that absolute value by itself? The answer is no. Okay. Well, how would you get rid of that 4 times that? Well, if you wanted to get rid of it, you can just divide both sides by 4, and then you have the left side by yourself. Okay. You can solve it. It'd be what? Absolute value of p minus 3. What is that equal to? Absolute value of 2p plus 8, all divided by 4. You can solve it and now go plug your negatives in. That's one option, just like before. Okay. Just so you're clear, this one would be 2 problems. You'd have the original. P minus 3 equals absolute value goes away when you split them up. Equals 2p plus 8, all divided by 4. And your other equation would be p minus 3 equals a negative, there you go, negative, I'm just might as well put a negative 1 up here just so you can see it, makes it easier. A negative 1, 2p plus 8 all over 4. Okay, and this whole thing would be multiplied by a negative 1, which can get a little complicated as you see there. So what I would recommend is not doing it this way, but it would work. What I wanted to show you, I'm going to erase all this here, because I said you have to have a denominator, you have to multiply by negative 1 that entire side. Here's what I want you to do. Notice that this side is the absolute value is not by itself. Okay, that 4 is messing it up. Let's stop and go over here to the right and look at this one. Okay, look at the one on the right. Right here, this absolute value of 2p plus 8. Is that by itself? Yes. Okay. So that's by itself. Let's set up our 2 problems. Again, the original 4. Get rid of the absolute value. These become distributive property type problems. P minus 3, those parentheses, equals 2p plus 8. There's your original. Now write the same thing, only negative. Again, we're talking about this one right here. So that's the original. That doesn't change, but the other side does. So this negative 4 out front, the whole thing gets multiplied by negative 1. So it's negative 1 multiplied by 4, and it's p minus 3. So take care of the insides. We'll do the hard one over here on the right first. I see 4 times p inside is 4p. 4 times negative 3 is negative 12. Okay, this whole thing again is multiplied by negative 1 equals 2p plus 8. Then I'm going to do this distributive property again. Negative 1 times 4p is negative 4p. Negative 1 times negative 12 is a positive 12 equals 2p plus 8. Continue solving. Add 4p, add 4p. That's 6p plus 8 over here equals 12. I moved the variables right, so let me move the numbers left, and I get an answer of, scroll down a little bit, answer of 4 over here equals 6p divided by 6. P is equal to 4/6, which is 2/3. Okay, so that's simplified. So that's one of the answers. We can plug it in and check in a minute. We can do that. Before we do that, let's solve this one too. Distributive property. 4p minus 12 equals 2p plus 8. Subtract 2p from both sides. That gives me 2p minus 12 is equal to 8. Add 12. Gives me 20 equals 2p. And then, scroll down a little bit more for you. Divide by 2, p is equal to 10. So our two answers are 10 and 2/3. Again, with absolute values, you might want to go back and check and make sure it works. So let me check with the 10. Let's check with the 10 first. 10 here. 10 minus 3 is 7. Absolute value of 7 is 7. 7 times 4 is 28. Over here is 10. 2 times 10 is 20. 20 plus 8 is 28. Does it work? Yes, we just confirmed 10 works. Over here, we have to do 2/3. This one's going to require a little bit more work here. Let's go down to the bottom and do this one. 4 times, so you have 4 times, was it p plus 3, I think, equals, make sure I have that right, p minus 3, 2p plus 8. 2p plus 8. This one's minus right here. Make sure I switch that. P minus 3. Okay, so there it is. Let's now plug in our 2/3 and see how it worked. So we have 4 times 2/3 minus 3, which is a negative 2 1/3, which is just 2 1/3 positive after absolute value. That's going to be multiplied by 4. Over on this side, plug in this. 2 times 2/3 is 4/3 plus 8. Need a common denominator, so that'd be 3 and 3. It's 24. That's 4/3, so it's ends up giving you 28 over 3, which is on this side. Absolute value is positive anyway, so 3 times 9 is 27, so 9 1/3 over here for your final answer on the right. Finish over here. 4 times 2 1/3. Let's see if we can get down to 1/3 to make sure it works. 4 over 1 times improper fraction, 7 over 3. Ends up giving you 28 over 3, which again is 9 1/3. So you'll notice that both of these work. Both 2/3 and 10 both work, so they're both possible answers here for both of them. Okay. So what did you get across here? Yes, it's a lot of work. Yes, a lot of equations, but your same goal: get the absolute value by itself. Once it's by itself, write the original, then make the entire other side negative. Hopefully that helps out a little bit and give those 5 a try tonight.